now that we have calculated that the delta H is 3.00 times 10 to the second, or 300 kilojoules per 1 mole of NaOCl. And we know that a mole of reaction, because the question wants in kilojoules per reaction, mole of reaction. So a mole of reaction in this question means 1 mole of Na2S2O3, 4 moles of NaOCl, and 2 moles of NaOH. So therefore, we put this equation 300 kilojoules per 1 mole NaOCl. And we know that 1 mole of reaction is 4 moles of NaOCl. So 4 moles of NaOCl over 1 mole reaction. This will give us about this one will give us we can cancel out this unit, so that it will be 1.20 times 10 to the third kilojoules per 1 mole of reaction. But know that the reaction is exothermic. We can see this from the graph. The temperature of the calorimeter increases. Therefore the reaction is exothermic. Exothermic has a delta H of negative. Therefore we put the negative sign here. So it's actually negative here. The student repeats the experiment, but this time doubling the volume of each of the reactants as shown in the table below. So you double the volume from 5 to 10. The magnitude of delta H in kilojoules per mole reaction calculated from the results of the second experiment is the same as the result calculated in this experiment in part EII. Explain this result. So since we have double volume and concentrations are stay the same, the number of moles compared to the first experiment, the number of moles also doubles. And since the number of moles also doubles, the total enthalpy change will also double. So doubling the volume of the solution doubles the amount of moles of NaOCl that reacted. So it should also double the total enthalpy of a total enthalpy change. But for kilojoules per mole of reaction, since the number of moles also doubled from seen from the volume, the doubling in enthalpy change and the doubling for mole number will cancel out. It's like having two times the amount of kilojoules and 2 times the mole of reaction. They will cancel out and eventually they will give us the same result. Therefore, the enthalpy change in kilojoules per mole reaction will not change. So just to summarize, the enthalpy is given in units of per mole of reaction. So when you double the mole number of the reaction, it will also double the total enthalpy change. I'm going to bold total here. Because it's the total enthalpy change. The two doubling will cancel out, so you will not have a change in delta H in kilojoules per mole of reaction. Write the balanced net ionic equation for the given reaction. So if you observe the reaction, you will see that this is ionic. It's 2 Na plus ions and one S2O3 ions, and this is also ionic, Na plus and OCl ions, Na plus and OH minus ions, 2 Na plus and SO4 2 minus ions, and Na plus and Cl minus ions, and H2O is not ionic, so we are not going to separate it. So all ions except water, ions will break apart. So we can see the following reaction. What I'm going to do is I'm going to take a screenshot of this and put it here. So this will separate into ions. So Na2, 2Na plus, and this will become ion. So S2O3, and this is 2 minus, plus 4 times Na plus, plus 4 OCl minus, plus 2 Na plus 2 OH minus will give you, so 2 of Na2, so it's actually 4 Na plus and 2 SO4 2 minus, so 2 SO of 4 2 minus, plus 4 NaCl, so Na plus 4 Cl minus, and water doesn't break apart, so we'll get H2O as itself. So from the left and right, we can cancel out stuff. The 2 Na plus and 4 Na plus and 2 Na plus here will add up to 8 Na plus. And we have 4 Na plus and 4 Na pluses here. So these are spectator ions that will be removed. So I'm going to cancel this out. So eventually we will get is this. And this. And this. This will become this one. 2 SO4 2 minus. And 4 Cl minus and H2O. So this will be your ionic equation for this reaction.